Welcome to today's air conditioning maintenance course. My name is Marcos Serratos. I'm an instructor here at CWI. The purpose of this course is going to describe the system purposes and essentials. We are going to test your knowledge on the AC system. Then I am going to do some system overview. Kind of these test your knowledge and system overview are going to go hand in hand. So that way we can just have an idea of how the system works. Then we're going to talk about 609 certification, and you're going to have the opportunity to take your 609 certification if you want to. And I have a lot of good information so that you can pass this exam. Then we're going to go into basic troubleshooting and discuss some of the troubleshooting basics that you guys need to know. And then we're going to finish off by looking at an ASC questions in regards to the HVAC system. So let's get started. The very first thing I want to discuss is what the purpose of the AC system is. Now that is to transfer the heat from inside the cab to the atmosphere or outside. As we all know, heat cannot be removed. We cannot get rid of heat. All we could do is just transfer it from one area to another, and that's what the AC system does. Now when it's doing this, it provides three benefits that are very important to understand. The first thing is going to be driver comfort. Fatigue is reduced when the environment of the vehicle is comfortable, meaning we all know that school buses get extremely hot just due to their poor insulation. So keeping the driver comfortable is going to keep him awake, is going to prevent him from feeling drowsy or feeling sleepy, not being able to pay attention to his route, to his students, to his bus, right? So making sure the driver's comfortable is very important. The other thing that it does, it provides vehicle safety. This is also as well for the driver. The AC system dehumidifies the air, preventing windows from fogging. Now, we use this feature when we are turning our defrost setting, and we'll discuss a little bit about how it dehumidifies the air when we put it on the defrost setting. The other thing that it does, it filters and cleans the air in the cab environment. So therefore, it cleans the air, it dehumidifies the air, and it keeps the driver comfortable during this route. These are three benefits that also serve a purpose of the AC system. Now, the primary purpose is to transfer the heat from the cab to the atmosphere. Now, the AC system is going to be composed of a couple of subsystems. The first one is going to be the electrical system. The electrical system is going to transfer electricity to the control and protection devices, and then you're going to have the refrigerant system, which is going to convert refrigerant from a liquid to a gas, and then from a gas back to a liquid. And then it's also going to be the primary system that transfers the heat from the cab to the atmosphere. Now, one thing we have to understand about both of these systems, if we're going to have to diagnose an AC problem, then we have to figure out what system has failed. Is it the electrical system or is it the refrigerant system? Now, in order to diagnose any system, we first must have to understand the system. That's like step number 2 in the troubleshooting guideline that I give my students when I teach them about any system or when they're diagnosing any system. The very first thing you need to do is you got to verify that the problem exists. The second thing you need to do is understand the system. Pretty much get all the information you can about the system before you begin to diagnose it. If we begin to diagnose either or of these systems and we don't have all the information, we can create a problem. And so it's very important for us to understand that there is two systems within this AC system. Now, before we move forward, I want to talk about some system essentials. These are things that are going to be required for any system to function and work correctly. The first thing I want to discuss about systems is that most systems will have a subsystem or will be tied into another system. For example, this AC system has two subsystems that we just discussed. But the cooling system is also going to have the cooling system where the coolant flows through the system, and it's also going to have an electrical system that sends signals to the engine control module to let it know, like, hey, my coolant's too low. Either turn on the low coolant warning light on, or derate the truck or derate the bus, right? So every system is going to either have a subsystem or is going to be tied into another system. And for the most part, Most of those other systems are going to be electrical. The other thing is that every system is going to have 6 essential components. That's going to be a power source, protection, connection, a purpose, control, and storage. So if we talk about an electrical system, the power source, that's going to be the battery. Protection, that's going to be fuses. Connection, another form of protection in an electrical system is going to be a module, an electronically controlled module or electronically controlled unit. Connection, that's going to be our wiring. The purpose is going to be our load. So whatever our load is in an electrical system, that's going to be our purpose. If it's to turn the lights on, then that's the purpose of the system, is to turn the lights on. Control, we're going to have switches, we're going to have control modules, but there's going to be a form to control the system, and there's always going to be storage. Now in an electrical system, the storage and the power source are going to be the same one. The battery stores the electrical potential and is also the power source for it. But if we were to discuss a cooling system, in a cooling system you have a power source, which is going to be your pump. Your pump provides the movement or the flow of coolant through the system. Your protection is going to be your relief valve or bleed valve, anything that prevents the system from overpressurizing. The pressurized cap on the coolant surge tank, that's going to be protection, right? You're going to have connection, that's going to be all the tubes. The purpose of the cooling system is to transfer heat from the engine to the atmosphere, and then the control is going to be your thermostat. That's actually what opens and closes the coolant flow, right? You're also going to have some sort of storage, which is going to be your coolant reservoir. So as you could see, it doesn't matter what system we discuss, there's going to be 6 essential components that are going to be, in every system. Now, all systems are going to transfer or convert a form of energy, and that is what their primary purpose is. For the AC system, it's to move heat from the cab to the atmosphere. For the cooling system, is going to be the same thing. Now, when I talk about forms of energy, what I'm talking about is heat, electricity, mechanical, kinetic, radiant, chemical, or magnetic. These are all forms of energy that we use in our systems to control them or to serve a purpose, right? For example, the brake system. Let's talk about the brake system real quick, just to give you an idea of what I'm talking about. In the brake system, we have kinetic energy. Kinetic energy is the energy that's moving, right? So movement. We have the truck or the school bus moving forward. That's kinetic energy. We're going to convert that kinetic energy into heat, and we use the brake system to do that. So in a brake system, all we're trying to do is convert kinetic energy into heat, and we use the brakes to do that. Again, for the purposes of the AC system, we're using the movement of heat. All we're doing is transferring heat from one place to another. So in a brake system, we're converting one form of energy to another, and in the AC system, we're transferring. So you're either going to transfer or convert all these forms of energy. Now, this is very important for you to understand so that you can troubleshoot these things. You have to understand what their purpose is of each system, because one of them is to move forward. The drivetrains system, that's the purpose of the drivetrains is to create kinetic energy using mechanical energy, right? So we use mechanical energy to create kinetic energy. So I hope this all makes sense, and I hope this all serves a purpose for your better understanding of systems. Because once you understand what the purpose is of something, then you can better understand it. And in the AC system, we're going to be using a lot of forms of energy. We're going to be using most of these forms here. There is a magnetic source. We do see some chemical reaction based on pressure. We're going to see, we don't have much kinetic energy, but we are going to have an electrical. We do have some mechanical, and there's not going to be any radiant energy, but we are going to use a lot of these forms of energy to understand. Now, before we get to diagnosing the AC system, what I want to do is I want to know what you know. What do you know about the air conditioning system? Now, the very first system I want to talk about is the refrigerant system. Now, we're just going to do a quick overview of the system so that you can have a clear understanding of how the system works. Now, first thing, we're going to have a high side and we're going to have a low side. High side meaning high pressure, low side meaning low pressure. And so what I'm going to do is I'm going to run through the system real quick and how the refrigerant flows through the system. We're going to start at the AC compressor, converting it into high pressure gas. So it's going to take this, it's going to convert our refrigerant into a high pressure gas that's going to move down to the condenser. At the condenser is going to cool this high pressure gas and convert it into a high pressure liquid. Now it's a high pressure liquid moving down the system until it gets to the orifice tube or the expansion valve. At the expansion valve, it's going to go from a high pressure liquid to a low pressure mist. It's really not quite a gas at this point. It's more of a mist. And so we're going to turn it into a low pressure mist. That low pressure mist is going to go up to the evaporator. Now, in the evaporator is where we turn the heat that's inside the cab and we suck it in and move it out to the atmosphere. And at the same time, when that heat is moving through the refrigerant, it is boiling the refrigerant, causing it to go from that liquid mist to a gas, because it's changing state at that point. It's boiling it. Now, once it gets boiled, it becomes a low pressure gas, and that low pressure gas goes back to the AC compressor. And this right here is pretty much how the refrigerant system works. Now, we are missing one component. Can you tell me what component we are missing at this point? Now that we understand some of the basic components of the refrigerant system, let's talk about the electrical system and what it does. Now, two of the things that it does is that it protects the refrigerant system, and it also controls the refrigerant system. So in order for us to not overpressurize or shut the system down, we're going to have to use electrical system in order to do that. Now, this electrical system could have fuses, it can have relays, it can have switches, and it can also have sensors. Now, the electrical system, not only does it control and protect the refrigerant system. Now, if we look at the refrigerant system real quick, now we understand that there are 6 essential components to every system, right? And if we talk about the refrigerant system, the electrical system protects it and controls it. What provides power flow or flow of energy through the refrigerant system, that's going to be your power source, and it's going to be the AC compressor, right? It's going to pretty much provide that source to move the refrigerant. The purpose of the refrigerant system is to move the hot air inside the cab and move it outside to the atmosphere. So the transfer of heat, right? That's the purpose of it. The storage, we talked about an accumulator and a receiver dryer, right? So we talked about those. That's the storage of it. So now we've discussed the 6 essentials, including the connections, right, which is all of our AC lines. Now that we understand that, we also have other electrical systems that have nothing to do with the refrigerant system. So for example, you have this motor here, which could be this blower motor. That's an electrical system, and that has nothing to do with the refrigerant system. It's part of it, but it's its own system. And you need to be able to separate these 2 systems in case you're going to diagnose them or troubleshooting. So if your blower motor's not working, it can cause discomfort in the cab because your AC is not working, but now you have a blower motor situation. You have an electrical system malfunction. And so it has nothing to do with the refrigerant system. As opposed, if you have a leak here, now you have a leak inside one of these hoses, and you have something wrong with your refrigerant system, and that has nothing to do with the motor. So being able to distinguish or to separate each electrical system depending on what its job is. So the refrigerant system is very simple because it's a closed system. That means that nothing can get in and nothing can get out, or nothing is supposed to get in and nothing is supposed to get out. Obviously, if something gets in or something goes out, then we have a malfunction, and that malfunction could cause the system not to work properly. So the electrical system is going to be a bunch of different systems, and it's also going to be the control and protection system for the refrigerant. The other thing to note is that a lot of older systems are going to have relays and fuses and switches, but a lot more newer systems are going to have computers or modules sending information from one module to another, and then having that module send the power to the AC compressor to turn it on or turn it off. You're also going to have, for example, this is the HVAC main unit. So this is where you turn on and turn off your AC system in the cab. This is going to send that information to the SAM cab or to this computer here, and that computer is going to process that information and then send out a signal to turn on or to turn off the AC compressor. So now you have computers talking to computers. And so for this example, I had to look up 3 different wiring schematics to understand the system completely. As you can see, I have an AC compressor here that is turned on by the SAM cab. In order to better understand what I need to work or what needs to work in order for this to engage, I had to look up this. This schematic here tells me that I have a low air pressure switch and an ambient air temperature switch that are sending information, as well as a refrigerant pressure transducer. All 3 of these are sending information to the SAM cab, and based on this information, it's going to send out a signal to the AC compressor clutch. Also, if I had something wrong with one of my blend door actuators, then I have all 4 of them here that are being controlled by the HVAC controller or the HVAC unit. Also, these sensors are going to send information to the HVAC unit, and then it's going to take that information and going to send it to the SAM cab. So you have a lot. My point is that you have a lot of computers talking to other computers, and this can create a little bit of confusion if you don't understand the system. And that's why it's very important to understand the system, especially on newer model trucks or school buses. You need to understand really how it's all connected before you start removing components and then you create another problem yourself. So understanding the electrical part of it is another big part of troubleshooting. Now, before we get into troubleshooting, there's something that we got to discuss, and that's going to be the rules and regulations for using refrigerant as a technician. Now, Section 609 of the Federal Clean Air Act requires technicians who service motor vehicle air conditioning systems, or MVAC, to be certified. So everybody who's working on an AC system needs to be certified one way or another. Now, there's several different ways to becoming certified, but by servicing motor vehicles, what they mean is that if you are repairing a leak, or you're leak testing, or you're topping off the air conditioning system that's low on refrigerant, anything that requires dismantling or replacing of an air conditioning component, you're gonna need to be certified in order to do that. Now, there's typically 2 certifications that are the most common one. The 2 609 certifications that I know about are going to be through MAX or through ASC. Both of them are good certifications. It doesn't really matter which one you choose. Personally, I have a MAX certification, but I have all of my students go through the ASC certification. This ASC certification is going to cost you $19, but the price can range depending on who you go with, from $19 to $35. You can take this this course online, or you can have them mail it to you. You can mail in the exam, and they can mail in the money. So you can do it online, or you can have it mailed in. There's about 25 questions. Some have 30. I believe the ASC exam is about 30 questions. So 25 to 30 questions for the exam. Some of them offer an open book exam. If you guys go to any of the aftermarket 609 certifications, a lot of them offer an open book exam. ASC does not specify a lot of my students just have the book open, and then you're going to need a minimum score to pass, or else you're going to have to pay the $19 again and retake the exam. So what I'm going to do is I'm going to go over some of the important concepts that are covered in the 609 certification. If you have your 609 certification, that's good. This is just going to be review for you. If you do not have your 609 certification, I would highly suggest to take notes, and then in the next break you can go online and I could show you how to go online so that you can apply for your 609 and get your 609 certification. And if you do get it during this course, I could print it out for you in my office. So what I'm going to do is I'm going to go over some of the concepts that are covered in the certification, just to kind of get a refresher on how to handle refrigerant, what impact it does to our society and to the earth, and just kind of go over some of the questions that they discuss on the 609 exam. So when you're ready to take the exam, if you take good notes, you're going to be ready to take the exam after this just quick review of the 609. Okay, the very first thing we're going to do is going to go up top and type in 609 certification, and then this screen should pop up where you have the automotive service excellence first, refrigerant recovery and recycling program. That's where we're going to go. It's going to bring you up to this page where you're going to scroll down and you're going to see both your options. You could either do it online, like it says here, you just click right there, or you can mail in your quiz with your payment, $19, right? If you do decide to do it, mail it in, you can request a booklet, or you could download the PDF version. I have a lot of my students click on there and download this version using this little download button here. You download it, and now you have the exam, you have the book while you're taking your exam. The book's going to cover impact and health of the environment, EPA regulations, alternative refrigerants, and then responsible refrigerant management. All of this thing is going to be covered in the test. You're also going to look over leaks and detection, and then locating and repairing refrigerant leaks. It's going to cover a lot of good information. So to have the book is not a bad thing. What we're going to do is I'm going to show you how to do the online version. So you're going to click here, and it's going to bring you up to this page where if you have a login already, you just type it in up there and you hit enter. If you do not have a login, what you're going to do is you're going to scroll down, create a profile to make a purchase, and then it's going to bring you up to a page where you're going to enter all your information. If you have an ASC ID number, then what you're going to do is you're going to enter it there. That means if you've taken ASCs, you're going to put your number there. Once you put all your information in, you're going to hit submit the form, and you're going to be able to log in. Now I have a login, and you're going to end up in this screen right here. Once you log in, you're going to end up going to product catalog, and then you're going to hit the 609 refrigerant recovery program. From here, there's going to be two options. You can see the top one is if you're doing it for yourself. So if you're buying the quiz for yourself, do not buy the one, but buy the one above, as you can see. So don't buy the bottom one. Make sure you purchase the one on top. You're going to select that quiz, and then you're going to go to buy now. When you hit buy now, another screen is going to pop up around this area right here. You can't see it on my screen, but another screen is going to pop up, and then it's just going to walk you through the purchasing of the exam, and then you're going to be able to take the exam and get your 609 certification. So we're going to start looking at some of the stuff that's covered in the 609, some of those topics that we looked at in the booklet right now that if you downloaded it, and we'll cover some of that, and then at the end of this I'll show you again how to find this page so that you can go and take your exam and get your 609 certification if you do not have it. Now, as you guys saw, the book is broken down into 4 separate sections. The first section is going to be this one on refrigerant and the impact on health and the environment. In this section, it covers three major things. The first thing it talks about is going to be the ozone layer. Then it talks about the science behind what happens when we release refrigerant into the atmosphere. And then the last thing it talks about is the global warming potential of the different types of refrigerants that there are. So the first thing that it discusses is the ozone layer and how it's located about 10 to 30 miles above the Earth's surface, and how this layer filters out most of the sun's harmful ultraviolet radiation. And then it goes on to discuss the effects of the ultraviolet radiation, and it talks about how it can increase our chances of skin cancer. It has negative effects on the body's immune system. It could increase a number of eye cataracts, and then damage to vegetation, and adverse effects on sea life. And then it also causes higher smog levels. So that's about the ozone layer, and what happens when it gets depleted and creates higher ultraviolet radiation. The other thing it starts to discuss is about what happens when refrigerant gets released into the atmosphere, and it has these CFCs. It releases these CFCs, and when these CFC molecules get struck by sunlight, they cause chlorine to be released, and then that chlorine, the atoms in the chlorine react with the ozone layer to produce chlorine monoxide, which is not good for our atmosphere. So here we have the ozone layer, we have the science behind it, and the last thing it talks about is the refrigerant types and their global warming potential. And what this ends up translating into is how long it takes for that refrigerant to break down before it's completely gone out of the atmosphere. And so here we could see a variety of examples of different types of refrigerant and how their global warming potential are higher as we go down the scale. Now, the ones that are going to be in our industry are going to be R134A and R1234YF. Now, R134A has a global potential of 1,430, which translates to roughly about 14 years. So this refrigerant stays in our atmosphere for 14 years before it completely breaks down. And throughout those 14 years is causing this right here, these CFCs, to eventually create chlorine monoxide. Now, the newer version, the R1234YF, only has a global warming potential of 4, which translates to about 11 days. So you have 14 years versus a product that is now 11 days. Depending on who you talk to, there's a bunch of different answers out there. But regardless, the point is that our industry is still using R134A in medium and heavy duty trucks, but the automotive world, light duty trucks, and the light duty trucks, they've all gone to R1234YF ever since 2021. So what you're going to see is a lot of different components with the R1234YF. And what I mean by different components, I mean their design is going to be different. The condensers are going to have thinner passageways than R134A, just due to how this refrigerant is created, I guess, or the thickness or the viscosity of the refrigerant. Based on that, you're going to have different components. So it's very important to understand what system you're going to be working on. If you have light duty trucks in your fleet, or if you have some automotive components that you guys work on and they're newer than 2021, you need to understand which system you're going to be working on, and how to work on that specific system. The other thing that's going to happen is that both of these systems are going to use two different types of machines. You're going to have to need a recovery machine for R1234YF and one for R134A. So understanding that is very important. So at the end of the day, this is the important parts that you guys need to understand for this section, and take notes on. in the EPA regulations and alternative refrigerants sections, they're going to discuss two different things. Now, the main thing that they're going to discuss in EPA regulations is that only technicians who have completed their 609 training and have been certified can work on AC systems. If you do not have your 609 certification, then you should not be allowed to work on AC systems, and you can actually be prosecuted if they catch you working on an AC system and you don't have your 609 certificate. So it's very important. That's like the main thing that they talk about in the EPA regulations. They also discussed approved refrigerant handling equipment. They talk about classification, record keeping. They talk about prohibitions and required practices. So there's a lot of information in the EPA regulations. Now, in the alternative refrigerants, they discuss refrigerants that can be retrofitted. They discuss system hoses, system fittings, what type of couplers they use. So as an example here, we have R134A that uses a 16 millimeter coupler on the high side, as opposed to R1234YF uses a 17 millimeter on the high side and a 14 millimeter on the low side. So it's very important for you to understand these things or know how to locate these, because they're going to be asking you stuff like this about fitting sizes on the exam. Another thing that they're going to discuss is going to be, what type of refrigerant you could use for other systems. So if you have an older R12 system, which is one of the first refrigerants that came out, you can switch it over to R134A. But even though R744 is the one with the lowest global warming potential, you cannot use this one to retrofit any other system. Now, you could use R1234YF to retrofit R134A, but you have to understand that the system components are a lot different, and it might not work properly unless you replace all of these system components. So it's very important for you to understand which ones you could retrofit, which ones you can't. And that's something that we rarely do. I don't think you guys are going to be doing much of retrofitting, and I don't think I see it in the industry as much. The other thing that it talks about is about a standard J639, which gives details about the system designs, implementation, and services. And then it also talks about the fitting type, sizes, and each refrigerant. So for these two sections, they have a lot of things to cover, but these are some of the important parts that you guys need to be that you guys need to understand for your exam. It also talks about how each refrigerant or each piece of refrigerant handling equipment that is used to service motor vehicle air conditionings must be approved and certified. So these are very important things that you guys need to know if you guys are going to take this 609 exam. Now, most of the questions on the exam are going to be related to this section here, the responsibility and management of refrigerant. So this section is going to cover a bunch of different topics. It's going to cover safety. It's going to talk about recovery, recycling, and recharging equipment. It's going to give you best practices. It's going to talk about checking recycled R134A and how it is stored, the portable containers that are used to store it. It's going to talk about pressures and servicing hoses. There's just so much information in this section of the book, and this is why when you take your exam, most of the questions are going to be based off this section. So I'm just going to go over some of the things that I've seen and some of the stuff that I've noticed and some of the stuff that I think is very interesting, especially working on AC systems and what I found. The first thing that I noticed is if you're working on hybrid or electric vehicles, it's very important that you follow these special procedures that are in place to prevent you from getting hurt, because hybrid and electric vehicles have such a high voltage system that you need to know, how to take the system apart, and before you even start working on the AC system, you need to make sure you disabled the high voltage system. The other thing I found interesting is that making sure that when you're using an AC machine, that the shutoff valves are in the close position if it's not connected to the AC system. So just little things like this that I noticed in the book, that we can create good habits for us as technicians as we're working through these systems. It also gives us a list of things what we should never do when we're storing refrigerant, or when we're working with these systems, when we're servicing an AC system. One of the things that I noticed is to never store refrigerant in a disposable container. The other thing it talked about was before you check, before a container is stored with recycled refrigerant, the container must be checked for non-consumable gases. And what non-consumable gases are gases that will not condense into a liquid within the operating temperatures of a refrigerant system. So making sure that there's no air in these gases, because air is not gonna, air has water in it, right? So air has water in it, and if you have water in your system, it's not going to change its state. You know, as we discussed a little earlier about the change of state, it's not going to change its state. So making sure that you don't have air in your system is very important. Now, one of the things that I found extremely important was in the recovery, recycle, and recharging page on R134A. Most of us who've done AC work, we typically know what a vacuum is, and how to put the system in a vacuum. And when we put the system in a vacuum, I typically did 5 minutes. Most of the technicians that I work with did 5 minutes. But the minimum requirement for this section here is 2 minutes. So the system should hold a vacuum for a minimum of 2 minutes. So doing 5 minutes maybe was a little excessive, but I mean, I don't think that really matters. I just noticed that the minimum is only 2 minutes. Another part that this section is going to discuss is storage and using the proper containers, and what to do if you are, if the container is being tested, or if it's above a certain limit. It's also going to discuss conversions, and it's going to discuss approved methods for tank, filling up a tank. So one of the things that it discussed, that if a container of recycled R134A refrigerant is being tested for non-condensable gases, you make sure that you keep it out of direct sunlight. This is very important. Now, this is something that we should be doing anyways. We should always be making sure our systems are kept out of direct sunlight, because sunlight affects, any type of air, right, or any type of gas. That's why your tires become more inflated in sunlight. A basketball becomes more inflated in sunlight. It's just a chemical reaction that happens based on the gas and the sunlight. The other thing that it discussed is, what happens if the pressure is found above its given limit. And that what you should do is the vapor in the container should be slowly vented into the refrigerant handling unit, so into a machine, right? It also breaks down conversions, and it gives us a bunch of different types of conversions, how to convert ounces into pounds. And if you are working on a system and you're trying to figure that out, for the most part, what you could do is the math. But honestly, with technology now, you could just Google the answer, and try to and just ask Google, hey, how do you convert 40 ounces into pounds? And it'll let you know that it's 2.5 pounds. Now, it also discusses the approved, just like it talked about things you should never do, it talked about approved ways of storing refrigerant, but making sure that it's not above 60% of its gross rating. So there's a lot of information about storing refrigerant, a lot of information about identifying refrigerant, right? So this is another important thing that you're going to see on the test, is they might ask you, what is R12? What type of container is it in? Is it in a white container? Is it a light blue container? Is it in a gray container? And so this is another section. Another thing you're going to find in this section is how to identify a refrigerant based on the color of its container. As you can see, the thread, and also some of these have different fittings as well, but and the R134A and R1234YF have a right hand and a left hand, so that you're not supposed to be able to mess this up, right? So there's a lot of thought going into how do we prevent technicians from cross-contaminating the systems and making sure that they understand the color codes so that they can identify these different types of refrigerants. So for the exam, I would definitely take notes that, R134A is in the light blue and R1234YF is in the white and red with a red band. So just so that you have an idea of when they ask. Even write down, I would just write them all down just because it's better safe than sorry. So yeah. The last thing I'm going to discuss is standards, and there is a ton of standards. There's standards for everything. So I'm just going to go over some of these standards just so you can get an idea of what they're talking about. So for example, R134A, the equipment for R134A has to meet the standards that are set by SAE. There's a standard for the electronic leak detectors on R1234YF. There's going to be standards for the maximum levels of non-condensable gases in a recycling R134A should not exceed 1% or 1.5% of the volume. There's going to be a standard for the requirements of recovery, recharging, or recovery, recycling, and recharging this type of refrigerant. So there's going to be a different standard for R134A than there is going to be for R1234YF. And as you could see, these standards are all going to be like J2810, so J2810, what does that standard cover? That's the EPA standard for R134A, the recovery equipment provided. So the book just has a lot of standards. I don't know all the standards, but it's important for you to study them a little bit or get to know some of these. If I ask you who sets the standard for R134A, you should know that it's SAE. If I ask you about electronic leak detectors for 1234YF, you should know that that's standard J2913. You know what I'm saying? So like you have to at least understand the ones that you're going to be tested on for the exam. Now, there's a lot of information in this book that's very good, especially for technicians, the do's and the don'ts. I remember when I took this exam, I was still very young in the industry. I just it was a requirement for my college degree, so I went, I took it, and now that I go back and look at it, it's a lot of good information. Now remember, the booklet can be downloaded, so you can download it and then take your exam. And then anyone working on an AC system needs to be 609 certified. And if you're going to be working on the new R1234YF system or refrigerant, then you're going to need to update your certification. You're going to have to retake one of these exams or find a way to update your certification, because the 609 is not going to cover this new system if you have an older version of it. So I would have to give an updated one if I was to ever start to work on R1234YF. But at this point, what I'm going to do is I'm going to show you how to get back on ASC and log on to the 609 certification so that you can take the exam and you can get your 609 certification. Again, if you get your 609 certification, I'll print it out for you here at the college. It's only a temporary one. You'll get your 609 certification mailed to you when you guys fill out that information when you register to take the exam. So now again, to find this, you're going to go to Google and you are going to type in ASC 609 certification. From there, you are going to go down to the refrigerant recovery and recycling program. And you don't have to use ASC, but this is what I use, right? From here, we're going to scroll down. We're going to go to the online version. We're going to enter the campus there. Now, if you want to download the book, it's going to be on that page right there as well. And if you have a login, you're just going to type in your login and enter. But most of you guys are not going to have a login, so you're going to have to scroll down and create a profile to make a purchase. and then you're going to enter all your information in here. This is where you enter your address, so that way when you get your certification, they send it to you. If you have an ASE ID number, I suggest you locate that first so that you can tie that into your ASEs, and then you're going to register, submit the registration form. When you do that, you're going to enter this second page that I'm going to enter right now. I already have a login, but you're going to end up here. Once you end up here, you're going to go to the product catalog, and then that's where you're going to find the exam or the quiz, right? So ASE section 609 refrigerant and recovery program, and here is the recycling quiz. And remember, you're going to buy the one on top. Do not buy the one on the bottom, because that is for purchases with tax exempt status. So unless that's you buy that one, but most of us are going to select the one on the top, and then we're going to hit the buy now. Now, I hit the buy now and another screen pops up, but you can't see that screen. And the reason you can't see that screen is because it's a lock screen. It has, this is where you're going to type in your Visa information. You're going to give them everything you need to make the purchase. So that's why that screen doesn't pop up on this video. But once you make the purchase, then you're going to be able to take the exam. And then once you pass the exam, they're going to mail you your 609 certification. There is a temporary one that you can get now, so that you're able to print one out at the moment. If you want that printed, you just let me know and I'll print it for you here at the college. The very first thing I teach on troubleshooting is these 7 troubleshooting steps. These seven troubleshooting steps I learned at Freightliner. That's what I was taught there. I was taught how to use these steps to identify and make repairs. And I teach it now, and I still use these 7 steps to understand a system. The very first thing is going to be kind of obvious, but it's very important, and that's to verify that the problem exists. A lot of drivers just don't know how to use systems or don't understand how to use a new system. So it's very important that you actually verify that the problem exists. We don't want to troubleshoot something that is already working. And the other reason why this is very important is because sometimes problems are intermittent. Sometimes they work, sometimes they don't work. So it's very important for you to verify that there actually is a problem, because if there's no problem at the time, it becomes very difficult to troubleshoot any system when the problem is not there. So verify that the problem exists. Then what you're going to do is completely understand the system. So get all the information about the system and about what you could understand in regards to what you are troubleshooting. So obtain all the information about the electrical, information about refrigerant, and information about the compressor, if that's what you're troubleshooting. So just make sure you get all the information about the system before you start doing anything else. Now that you have all the information, you could start narrowing the causes and testing for the root cause. So steps 3 and step 4, you're just kind of going to go back and forth until you get to the root cause. Once you get to the root cause, then you are verifying that the problem is correctly identified. So you narrow down all the possible causes of the problem, and then you test for the causes of the problem, and then you verify that the problem is correctly identified. So 3 and 4, again, you're going to be doing back and forth until you get to step number 5. Once you get to step number 5 and you identified the problem, then you can make the repairs that you need for that problem. And then the very last thing you're going to do is you're going to verify that the problem is resolved. So these 7 troubleshooting steps have been a guideline for me in my career. And this is, again, something that I teach my students because it's a very good tool for you to have and understand whenever it comes to troubleshooting anything. Now, honestly, Freightliner has these 7 troubleshooting steps in their troubleshooting techniques for the electrical system, but this can work for any system. This is not just only for electrical system. It can work literally for anything and any system. The very first thing you're going to do when you troubleshoot is determine if your problem is going to be electrical or it's going to be refrigerant, mechanical, right? So is it going to be the refrigerant system or is it going to be an electrical system? You got to figure out what it is. And remember that refrigerant system is controlled electronically and it's also protected electronically. So the very first thing I like to do is look at the components of that system where I'm working at. So wherever the issue is, I want to look at the components that are part of that system. Now here, what I have here is all of the components in the HVAC system. As you can see, there's quite a bit of components. And if you are looking at a system and one of these components is part of it, but you don't know how it works, then that's what you got to do first, right? Is you got to obtain all the information, understand how the component works and what it does. What does the evaporator temperature sensor do? Obviously, it's a sensor, so it's going to send information to a computer, and you got to understand how it works. Is it a 5-volt reference? Is it a 12-volt reference? You just got to understand how each one of these components works before you can start diagnosing, before you can start figuring out what's wrong with the system. This is also going to point you in the right direction if you understand how these systems works. Now, another very important thing you need to know is if there's a logic ladder, which means that there's rules of engagement, right? So if the computer doesn't see a good temperature sensor, then it's not going to allow the clutch to come on, the clutch on the compressor. So you have to understand if there's anything of that sort that's going to prevent you from furthering your diagnosis. Now, one thing that I highly recommend is that if you work on Thomas school bus chassis, that you find the Thomas school bus rep today and get a login for their service literature. Their service literature is identical to Freightliner's, and Freightliner has great information in all of these systems. And even though they're going to be directly custom for a Freightliner chassis or a Thomas school bus chassis, a lot of the theory is going to be the same no matter what chassis you're working on. So the refrigerant system is going to be pretty identical regardless of the system you're working on. It's going to have a condenser, it's going to have a receiver dryer, a compressor, an evaporator, and it's going to have certain pressures. So a lot of the things are going to be the same. It's going to have sensors of some sort. It might have a binary switch or a trinary switch. This one has a high pressure transducer. So regardless of the system, that Freightliner or that Thomas school bus service manual or troubleshooting manual is going to help you at least get a little bit of an understanding of what you're going to need to look for in a system. So first thing I'm going to do is obtain all the information in regards to the system that I'm working on. Now, a lot of technicians like to skip that first step and just get into the preliminary checks. They want to get straight into visually inspecting the unit and seeing if they could see the fault or the issue before they even diagnose anything. And that's what you should do. You should kind of just open up the engine compartment and start doing a visual inspection. Sometimes you could see if there's oil in the condenser or if there's refrigerant leaking out of one of the hoses. You can see it just by doing a visual inspection, and that's what we're going to do first. We're going to do preliminary checks. I'm going to start by inspecting the drive belt and looking for any signs of looseness, making sure the drive belt itself is not cracked, it's not frayed, that there's not any chunks missing off of the belt. You guys all should be or know how to do a belt inspection, right? Because the belt is what turns the compressor. It's very important for it to be in good condition so the AC system could work correctly. Now, these little things, you may think they don't matter, but they do when it comes to the overall operation of the AC system. The next thing I'm going to do is visually inspect the clutch. I'm going to look for signs of overheating or damage or wear. I'm going to turn the clutch, and it should turn freely. There should be no binding. A lot of times if you hear noise in your AC clutch or your AC compressor, it's going to be due to that clutch wearing out, the bearings this side of it wearing out. So I'm going to do a visual inspection of the clutch, and I'm going to make sure that the gap is in good condition. A lot of technicians don't know what the gap is. The gap is going to be the gap between the clutch and the pulley. So here we have the pulley. This is where the belt rides on. This is looking at a clutch from the upward position. Now, there's going to be a gap in between here. This gap is going to be a specification. This is gap A, right? So this gap is going to be specified by the clutch manufacturer. So a Denso clutch is going to have a different specification than a Sanden clutch, and they're all going to vary. And so you need to be able to do the research and figure out what clutch you're working on and what the gap should be. A lot of the times, if the gap is exceeds in 3 different locations, then what you're going to do is you're going to end up replacing the clutch. On some clutches or on some compressors, you can adjust this gap. This gap is adjustable, and it just depends on the OEM and what they tell you. But here's a little bit of research that you need to do. The very next thing I'm going to do is I'm going to check for road debris buildup on the condenser coil fins. If the condenser is being blocked and you don't have good airflow going through your condenser, then you cannot properly, the state of change will not happen. Remember, at the condenser, that's when the refrigerant goes from a vapor to a liquid, and it's very important that it does that it cools off there at the condenser. And if it's not able to cool off, then you're gonna have a refrigerant system that's not gonna be working to its full capacity. So making sure that you clean it off, you could spray it with water. Just be careful to not bend the coils on the condenser or the fins on the condenser. The next thing I'm gonna do is I'm going to check my filters. There's going to be typically 2 filters in the system. There's going to be one for the recirculation that's going to be located inside the cab, and there's going to be an air filter that's typically outside for fresh air. So making sure that they both are in good condition, that they're not plugged. This again is going to affect airflow. So if you have I have poor airflow coming out of my vents, that's what you're going to be dealing with, is the filters. Checking the filters and making sure that they're in good condition is going to be the part of these preliminary checks. Now, again, these are designed to help you diagnose a problem right away. If it's one of these things, then you fix that first, and then you verify that your repair is fixed. And if that doesn't fix your repair, at least you fixed the problem and made the AC system a lot better. So we're going to start off with these. Once you have completed the preliminary checks, we're going to do an initial inspection of the AC system. Now, the preliminary checks were done with the vehicle not running. You didn't have nothing on. It was just more of a visual inspection than anything else. So for this inspection, we are going to run the AC system. So if you have any tools, if you took your flashlight, during the visual inspection or the preliminary checks, make sure you just get everything out of the way, because you're going to be running the vehicle at this time. For these inspections, for these initial inspections, what we're going to do is we're going to hook up our gauges. If we have air conditioning gauges, we're going to hook these up. Typically, when I was working at a shop, I did not have these. There were some technicians that had them. What I hooked up was the machine. The refrigerant machine. We had a Robinair and we had a Snap-on machine, so I would hook that up so I could get some pressure readings. The other thing that we did hook up was our laptop. We want to make sure that we could look at any electrical signals, and we could see if things are coming on, things are going off. If you have some sort of software where you can hook up, that's going to be a very important thing. Remember, we're now trying to figure out if our issue is from the refrigerant side or if it's an electrical issue, and this is the best way to do it, to hook both of these things up. The very first thing we're going to do is we are going to make sure that our system refrigerant on the high side is above 20 psi and below 450 psi. Now, this is just an initial check. I am going to go over pressures. A lot of the things about pressures is that they have a relationship with ambient temperature, so you have to make sure that the pressures and ambient temperature match. But just for an initial inspection, we're just going to make sure that the high side pressures are above 40 or above 20 psi, but below 450. The next thing we're going to do is we are going to make sure that our ambient temperature is between 40 degrees Fahrenheit and 200 degrees Fahrenheit. Now, the reason behind this is because on newer vehicles you have systems that use this ambient temperature and use the the pressures that you're going to get from transducers, that you're going to get from binary switches or trinary switches. So the pressure sensors and the ambient temperature sensor is going to be information that's going to be given to the computer to engage or disengage the air conditioning compressor clutch. So ambient temperature sensor is also going to be play a factor on a lot of newer vehicles. If it's an older vehicle, it might not play a factor, or it still might. It just depends on your system. For this particular system that we're working on, ambient temperature sensor is something that we want to make sure that we're looking at to further diagnose or to help us determine if it's an electrical problem or if it's going to be a refrigerant problem. The next thing I'm going to do is I'm going to make sure the evaporator core temperature is above 44 degrees Fahrenheit. If the core is, if this temperature is below 44 degrees Fahrenheit, the refrigerant system thinks that it's cold inside the cab, and then you no longer need the compressor to be kicked on or the AC clutch to engage the compressor. So the compressor is not going to engage the clutch if it's above 44 degrees. So making sure that the sensor is above 44 degrees is important. That way the AC clutch is on. I know I said that backwards right there and then, so you just got to make sure that it's above 44 degrees. If it's below 44 degrees, the AC compressor is not going to kick on. So this is just a number that you can use universally, but every system is going to have a specification. But again, this is, if it's 44 degrees and the AC clutch is not engaging, you have a problem in the refrigerant system, whether it's pressure or electrical, but you can get an idea of what's going on. Maybe the sensor is bad itself. So just an initial inspection that we got to do. The next thing we want to make sure is that the blower motor is working at all speeds, right? So making sure that in all position it's working. Again, these are initial inspections, so we're checking the whole system and making sure that it's working in all positions, whether it's fast or slow. And we also at this time want to make sure that the vents are working. So you want to make sure that if you are putting the blower motor or you're moving the vents on the feet, that it's coming out of the feet, and if it's coming out of the defrost setting, it's coming out of the defrost setting. So going through that whole system in the cab is very important. The very last thing we're going to do is make sure that the air compressor, the air system is above 60 degrees psi. Now remember, the condenser is designed to cool the refrigerant and turn it into a liquid, right? Now it cannot do that if you are idling and standing still. And so if you are idling and standing still, there's no airflow going through the condenser. So what you do is the fan kicks on. And a lot of fans use an air system to turn on and turn off the fan. So making sure that the vehicle is above 60 psi just to engage and disengage the engine fan is another very important thing. So these are the initial inspections that we're going to do. Now these initial inspections, when we see something wrong with this, then we have an idea of where to go. If our problem is going to be electrical or if our problem is going to be with the refrigerant system. But these initial inspections should help us determine what's going to be our issue. Now after your initial inspection, you determine that it's an electrical fault, then what you could do is look up the faults if there's any on your laptop, right? Sometimes the HVAC unit or the computer for the HVAC control system is going to throw faults that you can read. These faults are typically going to be on J1939. They're going to have an SPN and an FMI number, and you can look up and begin to troubleshoot that electrical fault. Typically you're going to have shorts, you're going to have opens, or you're going to have resistance issues, right? For that, you're also going to need to look up schematics. You're going to need to look up something like this. Now this is obviously on an older vehicle. You can tell because it's all tied in. Here we have our blower motor regulator. Here's our blower motor. Here's our resistor for the blower motor. You have some pressure switches and temperature switches. So you have a couple of relays and then some circuit breakers here. But for the newer models, you're going to have to look up some of those computerized signals that are being sent from computer to computer, and what computer is receiving information from what sensors. You're also going to have to locate resistance readings, right? So this is for the evaporator temperature sensor resistance reading, making sure that you know how to take resistance readings and take resistance readings. Now you could see that the temperature affects the resistance reading, so making sure that you got the right diagram for the system that you were working on. So a lot of the troubleshooting required for electrical is going to require you to look up and find service information in regards to your vehicle. And a lot of these sensors are universal, so you could take something like this and then just use it as guidance for yours. So when it comes to the electrical part of it, you're gonna have to kind of start all over, right? You've already verified the complaint. Now you're on step number 2 again, and that's looking up all the information, and then you're gonna start going downstream and seeing where you're not getting signal, or if it's the sensor that has failed. Pretty much you're starting over, you're troubleshooting completely from step 2, and you're going to start looking at electrical system faults. Now, if you guys want to learn more about troubleshooting electrical, Alex's class is definitely one to take. If you have the opportunity to take it today, take it today. Now, let's just say that we need to test the refrigerant system, because during the initial inspection, what happened was that everything seemed to be working okay. There was nothing obvious that was regarded in that initial inspection, but the driver's still complaining that the temperature is too low. So what do you need to do next? First thing we got to do is, we got to get the vehicle ready, make sure that it's out of direct sunlight, that we shut the engine down, and we set the brakes, right? So we got to make sure that we're setting up correctly. Next thing we're going to do is we're going to open the hood and leave it open for the entirety of this test. At this point, we're going to be testing the complete system and making sure that it's cooling down, making sure that our pressures are correct. So we're going to be that's the test we're going to be focusing on now. And then we're going to open the driver and passenger door. Again, leave those open for the entirety of the test. What we want is we just want to make sure that the cab doesn't get cooled off. We want to make sure that we are working the AC system to its maximum capacity. So if we close the cab and we leave the recirculation button on, then we're not going to get the best performance check that we can do. So we're going to try to put it under kind of a little bit of a stress. So then we're going to place a thermometer in the center of the dash outlets. Now the thermometer that I use is this one right here. It's a Blue Point. You can buy these from any shop. Most of you guys probably have one of these, but this is the thermometer I have. Mine looks exactly like this one over here, where it has the bigger numbers. But yeah, so you're going to place a thermometer there, and then you're going to take a note of the current ambient temperature. So you're going to, what's it like outside? What's it like in the room that you're working on? If you're inside the shop, you got to take note. Is it 7 degrees, 70 degrees inside the shop? Is it 80 degrees inside the shop? It depends, right? So just making sure that you have an ambient temperature that you could go based off of. Okay, the very next thing we're going to do after we have all the doors open, we have our thermometer in place, everything's set up, the truck is in a level surface, it's chalked, it's not in the field like this one. What we're going to do next is we are going to start the engine and run the AC for 15 minutes. And you are going to make sure that your speed is at least at 1500 RPMs. You can do this by setting the cruise control or just upping the speed, making sure that the speed is up. That way it engages the engine fan. So if you could engage the engine fan using your computer, leaving the fan on, that's okay. But just raising the engine RPMs is gonna raise the heat, and it's gonna raise the pressures, and it should kick the engine on, or the engine fan on. Then we're gonna set the climate control panel, or we're gonna set our control panel in these settings right here. We're gonna make sure that the air is in the face mode. So where your thermometer is at, you want to make sure you can take that reading. You also want to make sure that the air conditioning's on. So a lot of the times it's going to be a little snowflake that you're going to push to make sure that the air conditioning's on. And then you're going to make sure that the blower speed is on high and that the temperature is on full cold. So as cold as you can get it, right? You also want to make sure that the recirculation button is off, because what you want to do is you want to allow, you know, the outside air come in. So remember, you have two forms of getting air into your system, and that's going to be outside temperature and your recirculation, which is the inside air. So we want to make sure we're using the hottest air we can possibly do. Again, we're just putting this system to the test. Then we are going to allow the system to stabilize. We're just going to wait. You know, I would give it at least 20 minutes in these settings, allowing everything to kind of just settle and stabilize. Once it's stabilized, then you are going to need to look up a chart that's gonna be specific to the vehicle you're working on. Now this is gonna be the difficult part, right? You know, locating this chart. But I'll show you what a chart looks like. The chart that I'm talking about is gonna look something like this, where it has the ambient temperature. So this is why you wrote the ambient temperature down, because you want to make sure that if it's 70 degrees and the humidity is low, then it's going to tell you what the temperature in your dash should be. And typically, rule of thumb, you know, if you don't have this chart here, is that it should drop 30 degrees unless your humidity is high. You know, if your humidity is high, or if it's medium, then you know it's going to affect how much the temperature coming out of the dash. So but for Boise, you know, Nampa, typically 30 degrees is what I used to do when I was working at Freightliner. Is, you know, if it dropped 30 degrees, I was happy. As you can see, 80 take away 30, that's going to be 50. Obviously they're saying that 42 is acceptable on low, 46 on medium, but as long as I got 50, I saw a 30-degree drop. That for me was good enough. So if it's 100 outside, they're saying that this thing could get down to 44. I was happy if it got down to 70. That should be a significant drop for the driver to notice. So so that's the first thing we're going to pay attention to. The next thing we're going to look at is our high pressure and low pressure. And as you can see, the humidity also changes the high side and low pressure based on, and it's not that much, right? So on the high side, you have anywhere between 70 and 118, or 78, I'm not 70, 78, between 178 and 118. Or I would just take, you know, the worst case scenario, 75 and 120. You're going to want to see these pressures here, right? So that's what you're going to want to see. Now, remember that these pressures are specific to the vehicle that I'm working on. They're going to change on every vehicle depending on the type of compressor they have, you know. So the compressor is different, then these pressures are going to be different. If the amount of refrigerant in the system, if the refrigerant's different, if it's a truck that uses more refrigerant or a school bus that uses more refrigerant, then these pressures are going to change. So there's a lot of variables that go into looking at pressures and understanding pressures. And for you to kind of plug something in and for it to be universal, it just really doesn't happen. So one of the things that I highly suggest is to look up the chart or locate a chart for a school bus and then use that as a universal thing, because once you have a school bus, you have, you know, that's what it is. This right here is for a day cab. So this has really nothing to do, but this is the only one that I could find based on the truck that I was working on. So the truck that I was working on, this is going to work just fine, but for something, you know, like a school bus, these pressures are going to be a lot different. Now, once you get your readings and understand, you're going to find one of these conditions. You're going to have poor heat rejection at the condenser, meaning that you take a temperature on one side of the condenser and take a temperature reading on the other side of the condenser, and you should see a drop. If you do not see a drop, you know, what does that mean? What can that indicate, right? You can have good cooling, but your pressure on the high side might be too high, right? So your pressures might be too high. So what does that mean? If you have poor cooling, what could that be due to? If your receiver dryer is icing up, that could be another condition that you could find during this test. Or if the system is very inconsistent, you got pressures all over the place. The temperatures in the dash are weak. They're not where they're supposed to be. Everything just seems very inconsistent. Then what does that mean? So what I'm going to do is just kind of go through each one of these and kind of explain a little bit of what that means. So if you have poor poor heat rejection, meaning that one side's too high, one side's not there's not a heat drop in here, then that can mean you have too much oil in your system, meaning that maybe somebody just replaced the compressor and they overfilled the compressor with oil. A lot of these times, the oil inside the system. Now, that's one thing I failed to mention throughout the lecture was about the oil. Now, we talked about the refrigerant in when we were discussing the 609 certification, but I didn't discuss the oil. So this system has oil in it to keep the compressor lubricated. That's the primary purpose. Not only the compressor, but like for example the thermal expansion valve, because it's a moving component, and it's to keep that as well lubricated. So the oil serves this purpose, but if you have too much of it, you're going to see a high reading on your high side pressure, and you're going to have poor rejection in your condenser. So that's one case that you could come across. What if you have good heating but your pressures are too high? That could mean there's too much refrigerant in the system. So if there's too much refrigerant in the system, that means that everything seems like it's working good, but obviously it's not. Your high side pressure is going to be way high. It's going to be too high, and so that can cause damage further down the road. High pressure can also turn off the system. If the pressure gets too high, then eventually the circuit protection is going to kick in and say, hey, this pressure is too high, and turn it off. So that's what happens when you add too much refrigerant, and this can happen again with another technician who just did a repair on the system, and they just put way too much because they couldn't find how much refrigerant in the system should be installed. If you have poor cooling, which is probably the most common thing we deal with, if cooling is good, typically a truck driver or a school bus driver is not gonna bring it in and complain about it. But if you have poor cooling, that's the typically number one reason why they bring it in, right? Because you're it's not getting cold enough in the cab. Now this means that there could be not enough refrigerant on in the system, and so by there not being enough refrigerant, that means more than likely you have a leak somewhere. There's going to be a leak in the system somewhere. So it's very important for us to understand when you have poor cooling, you more than likely have a leak, and your high side is going to be low, and your low side is going to be low. Both of these pressures are going to be low. As a matter of fact, one of the first things you guys are going to do is hook up those gauges. And if you hook up those gauges and you have no high side pressure or you have no low side pressure, then there's something wrong with the system already. You could tell right off top, right? So that's what's going to happen if you have poor cooling. If your receiver dryer is icing up, then there's likely debris or restriction in the system. Something got in. Again, this is a closed system. Nothing should be getting in. But if somebody's doing repairs, if the compressor becomes damaged and now there's little metal shavings in the system and they fail to flush it out, they just replace the compressor, then you can have restriction in the system. So typically this is another thing that is caused by a previous repair. And again, it doesn't show up right away sometimes. A previous repair failure can take a month, it can take a day, it can take 5 years. So this is a situation. If you have the receiver dryer icing up, it could mean that you have your TXV could be plugged, or your compressor is also hard turning. So that's gonna cause that, right? If you have very inconsistent system pressures and temperatures coming out of your vents, then that's going to be a contaminated or the incorrect refrigerant. Sometimes people don't know that there's a variety of refrigerants and they just put any refrigerant in the system. Another thing that just kind of reminded me of that, of people putting refrigerant in the system, if you have too much refrigerant in the system, they sell these little cans that you're not supposed to be putting in the system, but sometimes drivers say, hey, I need more refrigerant. That's probably why it's not working. And they go and put refrigerant in the system. So that could be another reason why you can have too much refrigerant in the system. So this is pretty much what you're going to end up once you do this refrigerant test. If you don't need to get to this point, then you're probably okay. Typically, after the initial inspection, you're going to have an idea of where the problem is. But if you don't have an idea of where the problem is, that's when you would test the refrigerant system to its full capacity by leaving the engine, open, by leaving the doors open, by making sure that the air that's coming into the system is the hottest air, which is the outside air, and then just understanding what you're doing when you're doing the test for the system. At this point, what I want to do is I want to talk about leak detection methods. And what I really want to do is ask you how you are locating leaks in the AC systems that you guys are working on. I want to know if you guys are using this tool over here with some soapy water, or are using this tool over here, and how successful, what's the success rate of using this tool. So I want to get your input and try to figure out, what pressure, how much pressure are you putting into the system if you're using this tool, and how are you putting, how are you doing this, so again, I just want to have a little discussion, so I'll push pause on the video so that we can discuss this a little bit. This is going to conclude our air conditioning maintenance course. I appreciate you guys for taking the time and coming to CWI to get some training. I hope that this course served the purpose and helped you understand the AC system a little bit better. And I hope that you can take this information and apply it to some of the jobs that you guys are working on. Again, thank you for coming by and taking the course.